Hi everyone. I hope you all are doing great. So let's study about chapter motion from physics, grade 9 Cbse. Let's understand the concept of types of quantities, that is, scalar and vector. Now, scalar is expressed only in magnitude, but it is independent of direction. But when we talk about vector quantity, it is expressed with magnitude and direction, it dependent on direction. So if we want to take quick example for scalar, we talk about distance. Okay, so it's scalar because it doesn't talk about direction. But when we talk about vector, one of the quantity, we can consider velocity, right? Because velocity is speed plus direction. So there are varied examples for scalar and vector quantities. So if we see the scalar quantities, like more examples here, we have length, SI unit is meter, symbol is M. Mass, SI unit kilogram, it's kg. Time, SI unit is second, symbol S. Electric current, ampere, capital A is the symbol. You will be studying about electricity chapter also in grade 10. Temperature, Kelvin, that's the SI unit, and symbol is capital K. Amount of substance, mole, that comes across your chemistry chapter, the symbol is MOL. And luminous intensity, that is SI unit is candela, so symbol is CT. So all SI units must be written in small letters as in Newton, but the symbols for SI units named after scientists must be capital as in capital N. So for unit for force, just an example, it's capital N. Let's understand vector quantities. Now, it is represented, if you see here, this vector which is above the letter, its unit is meter, symbol is small m. Velocity, vector v, meter per second is the unit. Meter per second, it's the unit of velocity. So it's mentioned here. Then acceleration, that is vector, meter per second square. Okay, so this to make it more clear how we write meter per second, or sometimes you find in the textbooks it is mentioned ms to the power minus 1. That is same thing. Okay, so it's meter per second or it is ms minus 1 is same. Okay, so don't worry on that. So vector quantities are expressed with these parameters. Like suppose example given here, it is about unit, numerical value of the quantity, or direction. For instance, a ball is displaced 5 meter westward. Now, what is one-dimensional motion? So when a body moves along a straight line path, its motion is said to be one-dimensional motion. For instance, the ball here moves along a straight path, so hence performs which motion? One-dimensional motion. So this is just to give you an outline. Now the concept of distance and displacement. Now distance and displacement, they are two quantities that may seem to mean the same thing yet have distinct or different definitions and meanings. What is distance here? It is a scalar quantity as I told you in the previous slide. Now that refers to how much ground an object has covered during its motion. Please remember this very important point. Then displacement, it is a vector quantity that refers to how far out of a place an object is, or it's the object's overall change in position. Let's understand the next term, acceleration. Students, it's very, very important that these physics terms need to be very, very clear to you, okay? So that when you will be solving the numericals, it will make complete sense to you all. Now let's understand what is acceleration. It is the rate of change of velocity. What is that? Rate of change of velocity with respect to time. So in simple words, if I have to explain it to you, it tells us how quickly an object speeds up or it slows down or it changes direction. So what is the formula? A is equal to V minus U upon T. Now what is A? Acceleration. What is V? Final velocity. U, initial velocity, and T is time taken. So when you have to define acceleration, this is the key word which talks about change of velocity with respect to time. Next comes the important part, that is displacement time graph. Now, when we talk about displacement time graph, if you see x-axis, we have time. For x, y-axis, displacement. And for slope, which I'll be explaining you more in detail in the later videos, that is velocity. When we have to calculate, that is meter per second. So here, if you see displacement time graph, looking at the graph, if you see the red line, which is straight, that means it is at rest. And when we see the straight line, this one, the second one graph here, that is, I'll just take a dark mark here, that is uniform velocity, and this is variable velocity. Okay. Likewise, we have the velocity time graph. Now, velocity time graph, what you need to remember is that area under the graph which tells us displacement. So here we are talking about the displacement, because what is velocity? It is displacement upon time. So velocity time graph, here if the first one graph which you see, the first one, this is uniform velocity, that is zero acceleration. Second is the variable velocity but uniform acceleration. Likewise, for the third one also, it is variable velocity, students, but it is variable acceleration. So looking at the graph you come across, whether it is a zero acceleration, uniform acceleration, or it is variable acceleration. There will be more videos related to graphical representation that will help you to understand and interpret the graph. Likewise, next we have displacement time graph. Now here if you see the adjacent graph here, which is parallel to the y-axis, it is impossible. Now what do you mean by that? It means that displacement increases indefinitely without any increase in time. That is indefinite rise in displacement at a single instant, and that is impossible. So please remember this, pause the video, go through these lines again, and I'm sure that will be helpful to you. Then we have acceleration time graphs. Okay, now here when we talk about acceleration time graph, it is area under the graph. We are talking about velocity. Now look at the first graph here, uniform velocity, that is zero acceleration. So in this, the uniform velocity and zero acceleration, you will find the red line which is on the x-axis. Variable velocity, the second graph, that is uniform acceleration. And for the third one, again, it's a variable velocity and a variable acceleration. So you can pause the video, students, and draw these graphs in your notebook and write down the headings as well. Now this is again the most important slide I want to say and explain. This is also from your textbook. When a body starts from rest, initial velocity is 0. That is v is equal to at, s equal to half at square, and v square is equal to 2as. So to remember this, you have to remember three equations of motion. In that we have substitute u as 0, that is initial velocity as 0. And if a body is moving with uniform retardation, A will be negative. Now when we say uniform retardation, the other word is also deceleration. So the equations of motion that has taken the form is V is equal to U minus AT, S is equal to UT minus half AT square, and V square is equal to U square minus 2AS. So here the negative sign, that means a body is moving with uniform retardation. And numerical number 1. A train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. So first and very important thing is that you have to write what is given. So initial velocity. Now how do we know that it is an initial velocity? If you see the question, a train is traveling at a speed of 90 kilometer per hour. So 90 kilometer per hour becomes your initial velocity, and you have to convert kilometer per hour to meter per second. Then you have a terminal velocity. Now brakes are applied terminal, or we term it as a final velocity. Brakes are applied so as to produce a uniform acceleration. That means we have to find how far the train will go before it is brought to rest. So it is again the final velocity, that is 0. Acceleration is already given, minus 0.5 meter per second square. Now we need to apply it here. We are talking about V, that is final, initial and acceleration. So our third equation of motion, which tells us V square minus U square is equal to 2AS. So therefore the distance travelled by the train, you just have to substitute the values in this. And when you substitute the value, you will get 625 meters. When you are substituting the values, children, you need to be very careful while you are doing the calculations. The train must travel 625 meters at an acceleration of 0.5 meter per second square before it reaches the rest position. So when you are doing these questions, just see to it that you can write these three equations of motion along with. That will help you to understand when to apply what. Numerical number 2. A motorcyclist starts from rest and reaches a speed of 6 meters per second after traveling with uniform acceleration for 3 seconds. What is his acceleration? Now here you can pause the video and just try to calculate, because here they have only asked us acceleration. What is the first step you have to do? Write what is given. Initial velocity. Now why initial velocity is 0, kids? Here you have to understand, a motorcyclist starts from rest. That means the object or the motorcycle was at rest position. That is, its initial velocity is at rest. What is the final velocity? It is 6 meters per second. Now, how do you know it's final? Because the question tells us that it reaches a speed of 6 meters per second. What is the time given? 3 seconds. And what is the formula? A is equal to V minus U upon T, which we have seen in the previous slide. And when you will calculate, to make it thing more easy, I will help you out. So what is the final velocity? It is 6 minus, what is the initial velocity? 0, divided by, what is the time given? 3. And when you will calculate, you will get A as 2. Please don't forget to write unit, students. It's extremely important when we are writing the final answer. Okay. Numerical number 3. An aircraft traveling at 600 km per hour accelerates steadily at 10 km per hour per second. Taking the speed of sound as 1100 km per hour at the aircraft's altitude, how long will it take to reach the sound barrier? Now here again, looking at the big values, students, you don't have to worry. Initial velocity. First thing what you have to do, write down what is given. What is the initial velocity here? 600 km per hour. What is the final velocity? 1100 km per hour. What is the acceleration given? It is given here 1100 km per hour per second. Don't confuse yourself. You can convert it into kilometer per hour square. So when you will convert it, or you can convert it into meter per second as well. That's absolutely fine. So A is equal to V minus U upon T. Now here what have we calculate? How long will it take to reach the sound barrier? That means we have to calculate the time. In the previous slide you have seen, they were asking about how far. When it says how far, that means you have to calculate distance. When it talks about how long, then you have to calculate time. Taking T as the subject, and you will calculate, you will get an answer of 50 seconds. You can even pause the video, do the calculations, and I'm sure that will help you. Numerical number 4. Find the initial velocity of a car which is stopped in 10 seconds by applying brakes. The retardation due to the brakes is 2.5 meter per second square. Now once again, what you have to do first, write what is given. Here we have to calculate initial velocity, so we put a question mark. Final velocity, it's 0. Now, final velocity, how do we come to know? Because it is stopped in 10 seconds. Then retardation, it is 2.5 meter per second square. Now, please kids understand it is given retardation, so we have put a negative sign. Time is 10 seconds. What is the equation of motion we'll use? Because here we are talking about V, U, A and T. So our first equation of motion, and when you will substitute the value, you will get an answer 25 meter per second. And numerical number 5. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Students, please also remember one thing. If it is given kilometer r to the power minus 1, it's just the same like kilometer per hour. So don't confuse yourself, okay? In the textbook, it is mentioned to the power minus 1. That means it's kilometer per hour, okay? It's kilometer per hour. So what is given? The initial velocity. So what is the initial velocity? 80 kilometer per hour, and you have to convert it into meter per second. Final velocity 60 km per hour, converted into meter per second. What is the time given? 5 seconds. Therefore, what is the acceleration here? V minus u upon t. And when you will calculate, you will get the answer minus 1.112 meter per second square. It also can be noted that the negative sign indicates that the velocity of the bus is decreasing. Very important part. What does slope of a distance time graph indicate? So the word slope, when you come across, don't confuse yourself. The slope of a distance time graph is, it is given by y2 minus y1 upon x2 minus x1. So we are dealing with what? Distance upon time, that is speed. So slope of distance time graph is speed. This you have to remember. Later, how to calculate the slope and all, that also will be explained. Let's understand the equation of motion now by using the graphical method, that is S is equal to ut plus half at square. So this is the equation where the symbols have their usual meanings. Now we have to derive second kinematic equation. So consider a particle which is moving with initial velocity u. Okay, the particle, it is moving with which velocity? With initial velocity. Now due to force, what happens? It gets accelerated with acceleration a and gain velocity. Okay, so we plot a graph between velocity and time. So if you can see this on the screen, the graph on the screen, let's understand further. Now we know that area under velocity time graph is displacement, as it is discussed in the previous slide. So what is displacement here? Area of rectangle ADCO. So if you see here, this is the rectangle ADCO plus area of triangle ABD. So can we name this as 1 and the second one, the area, as 2? So displacement, how we are going to calculate? By finding out the area of rectangle ADCO plus area of triangle ABD. So displacement will be equal to, now what is the area of a rectangle? That is again length into breadth, or base into height. Here if we understand this, okay. So, and what is the area of a triangle? That is the right angle triangle. So it is half into base into height. So what is the base here? If you see from O to C, it is T into U into T. So here we are taking base into height plus half into base. Now what is the base here again? Base is T. And what is the height? Height will be V minus U. So what is V here? If you see here, this is complete V minus u, that is the initial velocity that you see it on the screen. I hope this point is clear. So you multiply it and divide the last term by, And when you calculate this, or when you open the bracket, so you will get S is equal to ut plus half t into a. Now for v minus u upon t, we have substituted what? A, because that is acceleration, right? V minus u upon t, which is equal to a. So when you substitute this value, what do you get it? If you see it on the screen, children, S is equal to ut plus half at into t. So final equation, when you rearrange it, so S is equal to ut plus half at square. So once again, where v is final velocity, u is initial velocity, a is acceleration, t is time, s is displacement, and this is your required equation. Hope this point is clear. You can pause the video, go through the entire equation again, draw the graph, and that will help you. Now let's understand how to convert kilometer per hour to meter per second, as you have seen in the previous questions or the numericals, where uh, it's mentioned that the unit is given in kilometer per hour. So to change the speed of 6 meter per second into kilometer per hour. So what is the solution? To solve such type of conversion, first you have to make it in standard form. So these are the two rules which you have to remember. If the quantity is in meter per second and we have to convey it in kilometer per hour, then you simply multiply by 18 upon 5. And if the quantity is in kilometer per hour and you have to convert that quantity into meter per second, you just have to multiply by 5 upon 80. Even if you want to do the calculation by converting kilometer to meter and then divide it by 60 into 60, but when you will reduce it into lowest term, you will get the answer 18 upon 5 for meter per second to kilometer per hour, and 5 upon 18 for kilometer per hour to meter per second. So please remember, this is utterly important. And some important concepts. What term is used to denote the change of velocity with time? That is what? Change of velocity with time, as we have done it. So the answer will be acceleration. It is used to denote the change of velocity with time. Now give one word which means the same as moving with a negative acceleration. So a body moving with a negative acceleration, it is called retardation. Question number C, if you see, the displacement of a moving object in a given interval of a time is 0. Would the distance traveled by the object also be 0? Give reason for your answer. So your answer will be, the displacement of a moving object in a given interval of time is 0. In this statement, distance may be 0 or it not be 0. And when a body travels some distance and retain at its initial position, then displacement will not be 0, but distance will be 0. So hope these some of the important questions or terms which you come across when you're solving the numericals, it is clear to you. Now there are some questions on uniform circular motion. What remains constant in uniform circular motion? So if we say what remains constant, that is speed remains constant in uniform circular motion. So like if the particle, it is moving, so if it is moving in a circle, that means what is constant? Speed is constant. And what changes continuously in uniform circular motion? That is velocity. Because if you see velocity, that is speed plus direction. So if the particle is moving here, it is moving here. So it moves on and on. You will find that there is change in direction. So what changes? Velocity. And what remains constant? That is speed. So hope students, these are some of the numericals were being clear to you and concept was clear. Next video, we will be understanding more concept on force and laws of motion. So thank you, God bless you all. But don't forget to like, share and subscribe for more informative videos. Thank you once again.